Okay, question number 2 here says, fill in the chart below to show the relationship between torque and speed in gear trains. I've talked about this a bunch, so you should be able to do this really easy. All they want to know here is, if you have more torque, what does it create? If you have more speed, what does it create? Fill them in. Go. Okay, so hopefully you said more torque equals less speed. And more speed equals what? Less torque. Okay, going on to gear size. Listen to this. As the size of the driven gear decreases in relation to the size of the drive gear, output speed increases. As the size of the driven gear increases in relation to the size of the drive gear, output torque increases. You can remember all that, right? Piece of cake. No, you don't have to. This is confusing. I'm telling you, there is an easier way to remember this. Simply remember your bike. Think about riding your bike. And I know now, today we got some snow, you're not riding your bike, but you've been able to ride it a little bit this spring probably. When you want to go fast, where do you put the chain on the front? You put it on a big sprocket. Therefore, a big input equals speed. If you remember that one thing, you don't have to remember all this other stuff it lists. Because if one thing changes, it's the opposite. If two things change, it's the same. So a bigger input, if your input is bigger than your output, like the one I had up here, I should have left it. Let's say these are gears that mesh together rather than a chain drive, doesn't matter. If this is my input and this is my output, this is going to increase speed because my input is bigger. Okay, remember that one thing. So now, if we change these and my output is bigger than my input, now what? It's not speed anymore, right? We are now increasing torque. So we got to remember one thing rather than that whole thing they just listed. Big input increases speed. Remember that? You got it down. So now in number 3, they want to know, they say complete the chart below. Show the relationship between drive gear and driven gear in a simple gear train. You can remember drive or driven, you can remember input output. I like input output. So what I do right here where it says driven gear size, the driven gear is your output. I change it to output. So if this says output gear size, here's what they want to know. Got to get this so you can see it, but it's hard to. You got it in front of you though. So to increase torque, what has to happen to the output? So let's think about this. I got this increased torque. What happens to the output? It got bigger, right? So if the output gets bigger, you're going to increase torque. That means to increase speed, the output's going to have to get what? Smaller. It's going to be the opposite. So all you got to have on here is bigger and smaller, or increase and decrease. Okay? Got it. Now, page 4. We get a little bit tougher here. It is time to figure out gear ratios. It's kind of scary at first, but you know what? Not as hard as it seems at first. So here's what we're going to do. I'm going to take you through the sample one. I'm going to take you through the second one also. Then I'm going to stop, have you do the other 2 on your own, because there's 4 of them listed here. Have you do the other 2 on your own. And then we'll go through the whole chart and see if you did them all right. So you do 2 of them on your own. Okay, so the first one, they give you all the answers to, but I'm going to show you an easier way to do it. If you look at that explanation right here, they give a pretty long explanation there. We don't need to make it that long. I'm going to show you how to simplify that, how to make it a lot easier. When we talk about gear ratios and that means how fast one gear spins in comparison to the other gear, we talk about size, we talk about how many times they spin. So all this is a factor when we figure gear ratios. So you can measure the size of the gear by the diameter, the circumference, or easier yet, I think way easier, you just count the number of teeth. So that's what we're going to do, is count the number of teeth, or they've counted them for us and we're going to write them down. Later, you're going to figure out some gear ratios where we actually count the teeth on the gears. So let's do this first one. Here is actually, before we do anything, you're going to write down two rules about gear ratios. And this is going to get you through things later. I don't care where you write it. You got some space right here. You got some space right here. I would say right here, write the two rules I'm going to give you about figuring out gear ratios. Rule number one, okay, right? So write gear ratios. And then number one is output comes first, or output is listed first. I know that seems weird, but trust me. Say output is listed first. Then rule number two is if the output is bigger, if the output's a bigger number, torque is increased. I know that's opposite from what I just told you a little bit ago. You're like, Mr. Wakefield, wait a minute. You said that a bigger input increases speed. It does. But when we talk gear ratios here, we're going to be talking about how many times they spin. I'll show you why that's the opposite. Okay. So you're going to list output first. So look at this first line. The first one, we're going to list output first, input second. What is the number of teeth on the output gear? 40. What is the number of teeth on the input gear? 8. So our gear ratio is 40 to 8. But just like a fraction, we can reduce that. So how many times does 8 go into 40? 5 times. 8 goes into 8 once. So our gear ratio is 5 to 1.